Hello, SolarLune here. How's it going? Welcome to my indie game dev stream. I am SolarLune. I'm an independent game developer. I'm the creator of Master Plan. I'm the creator of Tetra3D. I'm the creator of a variety of things, Golang tools, stuff like that. And today, what I was going to do is work on Tetra3D some more. Basically, we're going to be replacing all vector usage in Golang 3D with our new vector that we started working on last stream. The reason why we're doing this is because ideally, when, well, there's a couple of reasons why we're doing this. I guess there's one reason why we're doing this. It's slower. It's slow. Like Tetra3D, it's not as fast as it could be. So by definition, it's going to be slow in comparison to where it hopefully will be once we're done. So the whole point is we're trying to optimize. Now, the core posit of this is essentially the vector class we've been using is this one, which is a very nice vector class provided by Cave Artborg. He goes by a different name now. It's not Quantum Castle, it's Quarter Castle, I believe. Quarter Castle now on GitHub. So it's a great vector, I said class, great vector struct that I definitely recommend. Works really well. But the thing is, slices are kind of slow because there are pointers to arrays, dynamic arrays, which is not really necessary when we're working with vectors, because vectors are, for 3D game development, pretty much a known length. It's either going to be 2D, 3D, or 4D vectors. So you never really need like an 8-dimensional or 16-dimensional or anything like that vector. One could argue that a matrix could be represented as a 16 length vector, but that it doesn't need to be dynamic, right? A 4x4 matrix is always 4x4. So it's slow to deal with slices. A vector that can be of varying sizes, it's slow to deal with that. It's slow to allocate a vector of varying sizes because it has to grow to the size that you're, specifying. It can be slow to perform math because you have to dereference pointers. There's a lot of reasons why this isn't as fast as it could be. So what we're trying to do is replace this, our external third-party vector, with this, which is our new vector, which is a struct. It's a struct of 4 float32 variables for X, Y, Z, and W. W being not really used that much in 3D game development, but or not really used at all for the most part in 3D game development, but it is used by the engine or by the framework that we're making here, Tetra3D. So you don't use it. If you're making a 3D game, you're not really going to touch W in a vector, but if you're making a 3D engine, you will, because you're going to be storing the perspective divide stuff in there, the perspective related code in W. Now, yeah, we're also moving from float 64s to float 32s with the basic idea that more vectors could therefore fit in cache. In actuality, I have yet to find a benchmark where this is proven, which is unfortunate because I was hoping it was going to be a significant improvement, but it doesn't seem like there's any improvement for using float 32s as opposed to float 64s, which is sad a little bit because it's like, you're trying to get something to be faster and it's not getting faster. But the upside is by using float 32s, we literally do have, or we should literally have, the amount of memory taken by a vector. So, if a Tetra3D game previously used, let's say, 133 megabytes of RAM, now it would use like 68, something like that, megabytes of RAM. 65, 67, 68 megabytes of RAM. So that's an improvement, a massive improvement, worth the investment. Also, finally, on top of all that, it takes time to allocate memory. So startup should also be drastically better. So we can show this by looking at some of these benchmarks. So we'll do that in a couple seconds. haven't listened to this one in a while. And hello to everybody in chat / everyone who will watch later. How's everyone doing? All right, so this is the old a benchmark of the old vector code that use the external slice-based vectors, where we basically just loop through and create a slice of 100 vectors and then populate that slice with 100 creations of vectors. It takes 37 nanoseconds per operation. This is our new approach. Well, let's go to the next one. This is basically creating a slice of a float64 array of 3 values. So you can see it's drastically faster, going from 41 or 37 nanoseconds per operation to 0.37 nanoseconds per operation. So literally 100 times faster. So I'm hoping that this means, pretty much a direct translation into a far faster time when first initializing a game, when first loading meshes into RAM from data. It was never really slow before, but this hopefully will mean it's faster. And then we also have a benchmark for using vector structs, which is pretty much the same. It's pretty much on the same order of magnitude. A little bit slower, maybe just a fraction slower, but not by much. Going from 0.33-ish nanoseconds to 0.39-ish nanoseconds. Next, we have math with the external vector code, where we basically take a vector, add another vector to it, and then compute a cross product on the two. This took 10,000 nanoseconds, 9,000, somewhere in that range. And our new code basically does the same thing, but now it takes 3,000 nanoseconds, so it's a lot faster. It might even be a little bit less than 3,000, so that's a drastic improvement. Hopefully this will translate again to a direct improvement, but that's good. That's real good. I think I have all of the code I need, or I would have wanted. I don't think we really need set 4D. We just have set. I think that we have basically the code we really I think we have basically the code we'd like, or everything's working as it should. Yeah. So we'll see when we actually get to the implementation if it improves. So this is going to be a little crazy, but we're just gonna hop in. We're just hop right in. We'll start with matrix. We'll replace these with float 32s because that's kind of important, because our vectors are going to be float 32s, so we need matrix to also be float 32. I think that would be a good idea. All right, and then let's see. So this is now just vector. It's gonna be one. Normalize angle. Oh, this is no longer, we don't have this anymore. It's in vector.x. Okay. Let's see. Matrix might be faster if it wasn't composed of a 4x4 array. Maybe it would be faster if it was composed of, if it was a struct that basically had like X, Y, M00, M01, M02, M03, M10, M12, etc. 11. But I don't really want to have to rewrite all that code. That's like a lot of code to rewrite. Because we can't refer to matrices like this anymore. I'll have to come back to that, to matrices doing, working that way. Quaternions, I guess those will also be float 32s. Because there's not really any reason not to. This might be a problem now that I'm thinking about it. See, the thing that's kind of like the most frustrating about this concept is that the internal math library takes float 64s, so we have to constantly convert between the two. So I'm wondering if it would be better to simply hold on, let me think. I mean, really, a quaternion is a vector. There's no actual difference. I mean, they're not the same, but they have the same arguments. All right, here's what we're gonna do. I can change this over to float 64 another time because I didn't notice any immediate improvement, so I'm not going to worry too much about float 64. That just feels like it's going to be a little bit too complicated. So this can stay float 64. Okay. Vector. Okay. All right, so let's see, go back to matrix. So this is correct. So we don't take a vector dot vector anymore. We return just normal vectors. X, Y, Z. Maybe I should make it normal. Oh, it is called unit. Well, oh. No, vector. Maybe I should call it unit. I'm not sure. Well, let's not worry about that right now. You know what? We'll just do it like this. Place vector dot vector with just vector. All right, so position is vector this. Scale is a vector like that. Unit. Row. Turn a vector. we'll have to rewrite this like so. Matrix 0. Wait. Alright, I think that's right. For I in range matrix row index. Matrix row index I. Okay, and then column is just this. But instead it's 0. Okay, let's see. Set row, so matrix row index 0 x W. Now this might be a problem. We'll have to see, but it feels like this might be a problem. Oh, I don't have an invert function? It's like I don't. Okay, we'll do this now. Oh, I guess I can just do it like this. Alright. Yeah, that's working now. Over here. Unit. These are normalized now. You know what? Let me just rename this to be unit. Doesn't like that, does it? No. We can always rename it later. Yeah, we can just go back here. Unit. Like that. There we go. And this, instead of magnitude, length, it could be magnitude. Okay. Let's see, so multvec multiplies a vector. Is there any, there is mult, okay, multimatrix, okay, multvec W. Is there any reason that we would not want to multiply the matrix by the, or multiply the vector by the matrix wholly? Do I ever use multvec? Yes. We could do it like that. I don't know how I feel about this. Yeah, we could do something like that, because I don't even know if we use multvec W that much. I guess what we could do... because we don't want to do more multiplications than necessary. So we could do it... Oh, Noah Malik says C++. Nah, this is Go. This is Golang. Also, longtime fan. Keep it up, King. Been a fan of your pixel art vids from a million years ago. Thank you. Thank you very much. Appreciate it. So the thing is, this API needs to be public facing, or is public facing. So I don't want to have like an uncomfortable API. Like if you multiply a vector, you shouldn't really have to think about it. So that means that we have either 3D or 4D. I'm trying to think of a situation where you would not want to include W. Let's leave it the way it is. Let's leave them as two different functions, because this allows us to have control, absolute control over if, you know, a vector gets multiplied the way you like, if we multiply all four components or not. All right, so we're almost done. New look at matrix. Okay, so this is just that. All right, so now x dot x. That's right? Yeah, x, y, z. Okay. All right, so that's basically it. So we can do like that to be a little simpler. Y equals z dot cross x 2 dot sub from dot unit up to from to up. And the upper vector usually plus y. Got it. All right, so this this seems like it's working. Like I don't see any issues here. We were able to get rid of vector. Yeah. Okay. So it's no longer importing. Vector should still be working all correctly. Let's test this out real quick. Oh, you have to have. Oh, I didn't know that. You have to have like the rest of your code has to work before you can run a benchmark. Okay. All right, so let's walk down the list. We got matrix and vector. Those are kind of the most important ones. We can kind of just go from there. So set row, okay, vector dot vector. Really set row, if it's gonna modify the matrix, we could probably just like, there's no reason to construct a vector for this. And I don't know if we use this anywhere else. Let's see. Yes. Okay, we do use it pretty heavily, but sometimes we pass in vectors. But I don't really want to have to construct a vector if I don't have to. Side and bounds, yeah. Like this, I mean, this is relatively free, but we probably could just completely avoid this constructing a vector for this. Like, we can just pass the arguments into set row. We don't have to give it a vector. But I guess that's fine. Let's just get it working first. Sphere world position. Okay, yeah. So this has to be. All right, here we go. I guess we could just wholesale replace vector dot vector with just vector like that, and just do it and fix any issues that. But the thing about this that I'm scared about is I won't know where these changes have happened really that easily. Although I guess I'll be able to review it. Submit search chain. Okay. So replace vector dot vector with just vector. Do it. 437 occurrences. Do it. All right. So now we're there. We're there, man. All right. Imported but not used. Okay. So there it goes. All right. So we don't need to clone vectors anymore. They by nature are cloned. They're always cloned because they're not passed by reference. They're not. We don't use pointers. Position, scale, and original local position. Okay, this is something like that. I guess we say new vector 0. Actually, I guess we don't need to do this because it doesn't matter if there's one in the last point, right? So we can just comment this out. This is, it doesn't matter if one's one here, it's either, but we don't need to clone these. There's no cloning these. Matrices are still cloned, that's fine, I suppose. Scale X, Y, Z. Position X, Y, Y and Z, okay. Don't need to clone this. I'm not sure, does this modify this? I actually don't know how this works because I've never really had this kind of a situation. I believe it should work, but I want to double check, so we're going to create a playground here. I just need to test something real quick. All right, type test struct x. Okay, so it does assign back. Snowmink says hi. Hello. So I mean, I assume this that like this should work, but I'm just like, I'm not sure how exactly this will work. You're late today. Oh no, it's fine. No problem. We're engaging in rewriting the entire API that this works on. I mean, I guess we don't really have to. Well, that's fine. Okay, PR. C. I mean, I guess it might be faster to just do something like this. Whoa. That's incorrect. It should be C. I prefer doing this by hand. I don't want to use the search because I'm just like, I need to see what I'm doing. Let's see. Oh, it's no longer. I don't need to see. We don't need to clone this. This is now X. This is now Y. This is now Z. X. Okay. Yeah, I'm not sure how like well this is going to work, but we'll see in a couple seconds. Not well, this is going to take longer than a couple seconds, but we'll see at some point. All right, node is done. Now we just gotta do the rest. Oh no. No, no, no. No, 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 no. Hold on, hold on, hold on. Normal vector, yeah, that's right. This is not. Yeah. No. Angle vector dot y. Oh, we don't use that. There we go. Back. X. See, okay. What do you guys think about the API names for global vectors that point in cardinal directions? Right, up, and down. Right, up, and left. Right, up, and backward. Should we call them XYZ, Vec X, Vec Y, Vec Z, Vector X, Y, and Z, direction X, Y, and Z, or maybe forward, right, and back? Give me your thoughts if you're thinking. If you have a, if you have an idea. I guess we just say okay, so add ooh, this is gonna be interesting, dude. This is definitely gonna be interesting. All right, let's see. Contact point equals point add. Okay. It's gonna just add a divide. Okay. All right, here we go. Oh, this is gonna be hack. All right, let's see. This is gonna be hack. Let's give it up for hack. All right, and then finally 2. And that's basically it. Vector. Can I use vector? Oh. Box size. Left axis. Oh no, you can't do this, can you? Oh no. Oh no. Is axis. I guess this will work. I'm getting close though. V0, V1, V2, add. Alright, well, whatever. Alright, let's see. Is, whoops, 0, new, 0. Okay. Alright, that's basically it. Maxter says, hey Solar, I don't have an opinion about the other conventions, but I definitely like XYZ over left, forward, left, and up for the axis aligned vectors. Oh, cool. Okay. Thank you. Thank you very much. That helps. Okay. So we don't want to use vector anymore. So value as vector. Oh no. So I guess this is why they do stuff like this. Vec exists. Track that value as vector AP playhead exists. Scale. Okay. Let's do this. Rotation. Wow, that's the same. It's the same. I prefer forward, left, and up because they're globally aligned, or I guess for vector specific too, because I'm used to it. Yeah, I like the name as well of like forward, right, up. That feels good, but at the same time, like we have to refer to them as something. I mean, we could just leave them, you know, relatively bare like this. Like just vec x, vec y, and vec z, but I mean, I don't know. It feels. I mean, I guess if you refer to it as Tetra3D.x, I feel like right is good, like right, up, and back, something like that. I gotta think about it some more. Okay, we can't compare it to nil. Nil. There's no such thing as nil checks anymore. If start that position is not equal to nil and props position is not equal to nil, start previous. Okay. XYZ isn't specific as much though. It's Y pointing up or down. It's X pointing toward positive or negative. Yeah, it's you have to know Y is up, X is right, and Z is backward. It says it in the documentation, but it doesn't say it on the variable. I think maybe that's why I don't like it very much. So maybe I'll rename it to be like right, up, and back. Yeah, I guess I could make one for every direction. So if there's no such thing as a nil variable, so a nil vector, because they're no longer stored as pointers. It exists. Let's see. Lottie, hello. Mr. Loon. Hello, indeed, it is I. Greatest to do it. Not at all. Let me get some different music while I'm working my way, eating my way through this massive job. Okay, something like that. How am I gonna do this, dude? Start the position of the Well, in what circumstance could the prop be nil? Basically, if it doesn't exist, vector, vector. If length key, back key raises equal to 0. At first. Y isn't always up. Up could be negative Y or Y, depending on the coordinate system. Well, in Tetra3D, the coordinates are like OpenGL coordinates, so they're not just like directions, or they're not just orthogonal vectors, they're directions. So like positive X is right, positive Y is up. You know, you can rotate rotate cameras and objects or whatever. You know, gravity can be whatever you want it to be if you even want gravity in there, but like Y is always up according to the coordinate system. Lucretia says, "What's up? What are you working on?" Hello. I'm working on replacing all of the vector code in my 3D rendering engine with my custom vector code, my own vector struct, which is a headache, and it's not even a headache because like it's impossible or it's that much work. It's because hold on. It's not even a headache because like it's just an insane amount of work, even though it is a lot of work. But it's a headache because I'm going from using pointers to not using pointers, so I can't do nil checks anymore, anywhere where I used to have vectors stored. Because that's what makes them fast, is not having to do nil checks. That's one of the reasons why they're fast. So I'm trying to figure out like how this would work. So if you get this is probably just not going to work, and I should just resign myself to this not working and come back to review it later. Actually, this is literally an impossibility. The only way if it's false is if there's no keyframes in an animation track, which is so unlikely that it's probably not even worth like worrying about. So value as vector should always basically give you something. So then we probably don't even have to worry about this. It's probably always going to give you a start. It's probably always going to give you start deposition. Start is... Really, we just want to know if it exists in the properties. Well, it's already there. We'll just assume... I think we should be safe to just assume. We could probably just... I'm just gonna kind of sunset this code here and just work with this. Something like this. Does that make sense? Do we have to do that? Or is it already stored? I don't think we have to do that. I think this is fine. No, it's okay. Prop stat, what is this? Oh, yeah, we can just assume here. We'll see. This, again, this probably will just not work. Can I use vexes? Oh, this should be effect way back. Oh, I replaced that. That's why I was like, what's going on with this? Okay. All right. So what's the common situation where you need to null check a vector? In this animation code, it was basically like I put a vector indicating the position of the current frame for, the position of the current node in a dictionary. So you can look, when you go to like animate a node, it can look in the dictionary and be like, where should this node be? But if the animation doesn't have, for example, any keyframes, then the dictionary won't have anything there. Or at least the dictionary, it will have put a nil in the dictionary. That's not an issue now, but there's other situations where I do null checks with vectors. I'll run into them as I bumble my way through this. All right, well, this is gonna be just kind of. This is gonna be kind of. This is gonna be kind of buns to work through this. I don't. This is gonna be annoying. All right, let's see. For dimensions, we want it to be probably dimension, like this needs to be dimensions 0.x. It's just those two, huh? Yeah. Z X. Bruh. Lucretia says, for that stuff, I'd wrap the vector in a keyframe element object or something. That's how I would solve it. Do you mean like, well, the whole thing is we can't do a nil check on a vector. That's the reason why we can't do a nil check on a vector, is because if you make it so that the vector is nillable in some respect. Let's see here. Oh, okay. So this is actually supposed to be this. Basically, if you make a vector so that it is actually nillable, that means there's a pointer to it, and if you have a pointer to it, it's going to be allocated to the heap that's slow. We don't want to do that, so we can't ever do a nil check on a vector. We can't make a pointer to a vector. We can't put a vector in a struct that has a pointer to it. The whole point is we can't do nil checks, or we can't make pointers. If we make a pointer, we failed, basically. Within reason. That's basically what we're trying to do. There are a lot of animation frames. I'm assuming there are a lot of animation frames. Well, there's only one struct that handles animation or one file that handles animation in Tetra3D. So there's not very many. It's just, okay, this needs to be X. It's not so much that like there's a lot of animation frames, but there's a lot of stuff in Tetra3D that is like, it shouldn't be too bad. We're already working our way through the majority of it, but it's gonna be time consuming to work our way through this. Oh Lord, we don't need to clone this out, can just be like that. Yeah, that's fine. We'll see how this goes. Whoa, whoa, whoa. I guess that's fine. Long day ahead. Yeah, kinda. How's everybody feeling? Everyone who's watching. How do you feel? How's your life? Oh, let's see. Right, we're almost through here. It's easier to align this stuff. I did not do that correctly, whatever. It looks so much cleaner with X instead of .0, 0, yeah. These were all Z's, right? Yeah. And I mean you can use. Oh, okay. I guess we could make a 0. Something like that. That's not that useful. It is cleaner. I mean, like, there is X, Y, and Z functions in Cave Artboard or Quarter Castle now. His vector package, but I didn't want to use them because that's, you know, invoking a function call just to get to index a variable that, you know, doesn't seem that useful for internal work. Maybe it's more useful for other people or externally. You don't need this. Okay, capsules next. Fortunately, it looks like most of it is just going to be this stuff where we just replace indexing. So we don't have to think that much or do that much. It's pretty much, you know, as you would expect. But there's going to be moments where we're going to be like, wait, what? Yo, huh? Wait, didn't this have a... Okay, that's how I did it. Is there like a key combo to move the cursor to the end? Add cursors to line ends. Shift Alt right arrow. Yo. Dope. Okay, that's what we're looking for. Alright, that's it for capsule. Let's see about sphere. Don't need this anymore. Triangles. Okay. This. Y and Z. Okay, so Game Novice says By the way, Solar, have you played any horror games? No, I don't play horror games generally. That means that I'm probably, hold on, we can just get unit, can't we? Boom. Let's see. Okay, I should probably just keep these. Is there like a? Oops. I feel like a there must be an add-on to give me like a copy paste buffer, like a palette copy buffer. Multiple copy paste. Enable user to copy paste multiple lines. Oh, no, I'm looking for like a buffer. Copy buffer. A searchable, pasteable history of your keyboard. Control Shift V to display your clipboard history. All right. This sounds like what I want. Let's see. Nothing in your clipboard history. Okay, so like I want to copy. Okay, so you can choose. Okay, that's fine. Broad phase. That's next. We don't need this anymore. We can save it. Okay, go down here. Oops. Go. Yeah, I don't really play horror games. I'm not a horror game person. This was pretty quick, this one. Camera, I'm gonna do camera last because I know that mess is gonna be crazy. I'm gonna come back to that idea. Give me an XYZ, thank you. Fast math, oh lord. Should I even still have fast math? I probably shouldn't, right? Because, like, we could probably add a distance squared function onto vector because we're making our own vector class. Yeah, we don't really need this anymore, do we? We don't need vector pools anymore. I think we don't need a dot product anymore. We could keep 2 radians, 2 degrees, and clamp. Pow, I suppose, is also useful, but the others can kind of get thrashed. I think we have to go back and do like rotate. This is gonna be slow, but that's better. I'm gonna change the music. Less than 1,000 problems now. Hey, we're getting there. Where's the yeesh emoji? Also, why is this dog barking like this? He barking for no reason. There it is. All right. Yeah, I'm not a horror game person. I feel like I would like to make a horror game as someone who doesn't like horror, which means that it would probably be more of a thriller, and either existential horror or like horror that is like, you know, not like a jump scare, you know, wow, demon. No, I feel like, you know, I would rather have a much more subdued horror. So I'd like to make a horror game. I think it'd be fun. Like, I think a horror game made by, like, I don't really care for RTS games as an example. So that means that I would love to make an RTS game that I would like, because most RTS games are just like, you know, for me, I'm just not a huge fan. Yeah, I was just like, it's not that interesting. So it's like, give me a character I can control and make it more like a tower defense game, but it's an RTS where you control your units and you have a dude who like you can run around and punch people. Now I'm interested. Give me an RTS where I can punch people. Now I'm interested. So like, I feel like, you know, as someone who doesn't like every genre, it would be fun to make games in genres I don't like, because that would, you know, be an entry, a very unusual entry. So a horror game that's not like dark and creepy would be an interesting horror game. Maybe a horror game where everything is well lit. You're always chased by some creature. You always have sound cues of him, you know, riding your back. Where you're like, he's right behind me. You always have that, like, you know, sound cue of maybe strings or whatever, you know, getting louder as he approaches. But there's no jump scares. There's no like, you know, anything like that. It's very much a like, yeah, Baldi's Basics, something like that. That's basically the idea. Well, hi, wow, welcome to my schoolhouse. All right, V1 sub V0, V2 sub V0, and then we need first dot cross second unit. Okay, point dot sub plane dot normal dot scale dist. Okay, doing this. Point dot distance AB. All right, so here's what we're gonna do, because we didn't have this previously. We'll make a function for distance. Which is just vec.sub other.magnitude. And then same thing for distance squared. Vec.sub other.magnitude squared. Then we can go back over here, and this was distance squared, yeah, because we're just comparing. So this is just gonna be point sub or point, whoops, distance squared. BC and CA, okay. Don't need this. This is going to be v2.sub v0. v1.sub v0 and point.sub v0. Then dot products of all of those. Okay, so now we just have end sub start. Hopefully this, wait, dot. We don't have dot anymore. We shouldn't have dot. Save. Dot. So this should be sub start dot. And then start add dot ca dot ca. Oh Lord, what have I done? All right. Oh my gosh, what have I done? Ah. All right, I'm getting there. All right, so that's done. Go back to broad. I keep like making more work and then having to go back and redo this stuff. But anyway, point dot dot segment divided by segment dot dot segment. Sphere pose. This was fast vector sub. Okay. This is squared. All right. Oh, return fast vector distance squared. Okay. What was this? Fast vector sub dot magnitudes. This is just distance. Okay. All right. So now dot cross A B B triangles. Okay. Axis. All right. Square. This was capsule top, right? Yeah. All right, we're getting there. We're getting there. All right, collisions, distance. Yeah, distance squared. All right. 816 problems. All right, we're getting there. We're getting there. It's all cool. It's all chill. It's all chill. It's all cool. I don't even know if we were using the backface spool, actually. Why? What the heck was I doing on this? What the heck? What the heck is this? I do it like this. Why am I calling camera world position 3 times? Why not just call it once? Why not just do it like this? Invert. There we go. Let's see. Y, Z, W. Vert, that is W. Oops. Those 3, yeah? Okay. 3, 1. Okay. So that's vert. All right. Oh no, we're in camera. I didn't look at what I'm doing. I'm gonna explode. It's gonna take forever. I guess this could just be a new vector. Oh, well, there's no out, huh? Yeah, there's no out vector. Because it returns, yeah. So we could just say vert dot. There we go. Vert equals. So that means that this needs to return a vector. Okay, we don't need this anymore. So yeah, okay. So clip to screen. Oh my gosh. Why didn't... Okay. I'm just like, wait a second. What? How many more do I... Okay. Okay. Problem, let's see. Like, this should be... Well, I guess that's fine. I guess it's fine. It doesn't really matter as long as it's kind of correct. Just squared. It's crazy. Like, you don't really think about how much code you write or how much code, you know, whatever you write touches. But then you get to the point where you're just like absolutely suffering, and then you're like, man, I wrote all this. I am dying. I am hoist of my own petard. I really made a mess of it, didn't I? Really made a mess of it, didn't I? That's basically how I feel. Just like, huh, I really messed this up, didn't I? Really fricked this up, didn't I? Oh, man. I should have just done it like this. Replace zeros with .x. Not that one. Let's see. Y. X. Y. That does look better though. Game Novice says, it's too bad we don't have any ability to have code graphs that could forecast the ways we get in trouble. Like, you wrote this function, here's all the ways it can mess you up. Here's all the ways. Like, I'm just imagining like a seventh grader's like a middle schooler's like book report like with like a PowerPoint with like a little star that like comes up. Like, here's all the ways they can mess you up. And you're just like, oh, this is interesting. Oh yeah, yeah. Oh yeah, I love it, love it. Can't get enough. It'd be crazy if this just worked first try. I'm almost positive it won't, but I'm kind of holding out hope as I work on this. Like, well, maybe it's not as scuffed as I thought it would be. Maybe this isn't like going to be a horrible waste of my time. Oh my gosh, why? There's a thick red block. We're just like, yeah, this is not going to work at all. All right, we're just gonna find and replace this right here. That too. Yeah, might as well just keep it going, I guess, right? From this point down. Oh, oops, this is incorrect. All right, we are basically done with, wait, hold on. We are basically done. Hooray. Let's see. All right, this seems fine. This seems fine. This seems... Path points, okay. Should be okay. Should be fine, should be fine. Dim is dimensions. I probably should make dimensions not be 2 arrays. Really, it should be like that, so it's not on the thing. Snowminx says instead of the logo, the more you know. It could be the more you can mess up. Basically, yeah. I guess there's no point in cloning dimensions, huh? Because, oh no, it's a slice, it's an array of vectors. Does that make sense? Oh man, let me just do it like, make it a struct and then make it like, I don't even know what to call it. Like a, basically like the extents, but like, or the corners. So I guess you could say bottom and top corner, or left and right, forward and back, min and max, there we go. There we go, so now we can just return. That. I guess you don't, there's no need to make a clone anymore. You just do it like that, then we say dim, max, sub, dim, min. And that's probably better because like before the dimensions being a slice or an array, you don't really know what the 0th dimension and the 1st dimension are. Like you kind of have to, like it says it represents the minimum and maximum spatial dimensions of a mesh, but it doesn't, you shouldn't have to look at the documentation for it to make sense. So now, do we actually, yes, okay. Yes, all right, so. now we can replace these. It's fine for now. All right. Cool. I guess we could also have just done like can we like we could multiply excuse me. I guess that's not that important. I'm trying to see how often do we do a times equal? Where you multiply something by, this could just be the scale. Like that. Trying to see how often we use this times equal scalar. Color is fine. Okay, we do it twice here. We do it once here. Or twice here. That's enough times, I think, to warrant making it a thing. What was the thing I was gonna? Oh, that's right. I did that already. Never mind. All right, we'll make it a thing here. We'll say vector multiply components. Usual 3D applications in vector. The fourth component W can be ignored and is used for usage. All right, there we go. So now we can just say dim.min equals dim.min.mult comp scale. Oh, return vector. There we go. Okay. Is this actually a problem or is it a solution? Let's go. Get dunked on. 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 I'm just quietly saying get dunked on. Pause equals pose dot divide. Float 64. Points. Add p.well position. Okay. New pose dot segment dot segment new pose 0 segment next. Okay. Okay. All right, we're working our way through, dude. That was the camera was kind of the heaviest part. I think we're kind of done with that now. Now I'm kind of scared because it feels like surely this isn't going to work. How about a horror game where the more you refactor, the more problems show up in the IDE? That's a pretty funny horror game. The more you refactor. Oh, mesh. Oh, mesh, please. There's probably 300 problems in this file. Oh man. All right. Let's make our way. Let's go back to a familiar dimension. This should be just 0, right? Yeah, there we go. Dimensions. Okay, so we can just do like dimensions 0 can become dimensions dot min. Okay, well this is basically. Were they both min? These were both min. Okay. Were these both min? No. Okay. Okay, now dimensions 1 can become dimensions max. Okay, and then these zeros can become .x. Alright, and then these ones can become .y, etc., etc. You know this. You know what we're doing here. Alright, .z. This was just add p? Yeah, okay. Sum. Oh, sum's a set of vectors. Maybe more than usual. Yeah, have fun laughing at my expense. Laugh it up. One day, I'll be dead. Alright? Like, I won't be laughing. I don't have that kind of luxury. Alright. What else? That needs to be .x. and this needs to be dot. Is working angle? Working angle is already a vector. We don't need to do that again. Distance squared. Yo, light's done. Okay, light's done. Mesh and model are both gonna be. Let's just do it. They're gonna be heck to wade through, but let's do it. Okay, dimensions. So these are X. Okay, these are. Nice. Max Y. Limit would probably be, let me see, limit. Wow. Let's see, position. All right, we'll start with this. All right, now we can do this. Actually, yes. Yeah, I guess we could have just done all of them at the same time rather than not doing that. Okay. Now we can go back. And then replace this with dot Y. Actually, this also, yeah, that's still dot Y. But not those. Okay. Well, we'll save that for later. And then up here still. Replace this with dot Z. We can't do this, can we? Do we actually call this anywhere? We don't? Okay, I'm just gonna... Alright. Alright, so we're finally through that section. We don't have to clone these. It was like max. Yeah, that's gonna be good. All right, so now this becomes this. This becomes this. And then these become .x's. What did I do there? Yeah, that's right. Okay. This becomes .y. And then this becomes .c. Don't do this anymore. All right. Let's see. Try.center equals this is x, y, and z. Indices 0. This is 1, this is 2. Okay, so it's x. Why isn't it? There we go. Like, I know why it's doing what it's doing. It's just I'm trying to work around it. There we go. All right, dimensions. That's fine. Okay. Only 6 more errors to go. Five more. Okay. There we go. Mesh is done. Okay, models next. Oh. Oh, Lord. What have I done? Why is this happening to me? I'm gonna try something that's probably ill-advised. I'm just gonna replace all 0 indices with X. Same thing for 1s with Ys. Same thing with this for Z. And just assume that most of them are, like, that's how... Okay, well, yeah, here's an example where this didn't work. But this is a lot easier to fix than... Yeah, I guess this is the right way to go about it. Back X, Y, and Z equals vert info. X, Y, and Z. Vert info. Okay, X, Y, and Z are not a vector. I mean, we could probably just make them a vector, huh? Mm, mm, that might be better. We just do it here. A chat controlled IDE. Oh, that would be Twitch programs Pac-Man. That could be fun. Cursor down. Cursor down. Chaos. Chaos. Praise Helix. Cursor down. Cursor down. Backspace. Cursor down. Control A. Backspace. No! Control Z. Control Z. Control Z. Control Z. Control W. No! Yeah, that would be chaos. I don't think it would get. I don't think you could possibly make anything, but that would be a lot of fun to just watch people freak out. All right. Yeah, if I'm gonna make a vector anyway, I think, am I making a vector here? The vector is up here. I might as well just make a new vector, huh? Because anything we do is just gonna make a new vector, so there's not a huge point. Lucretia says, have you played any interesting video games lately? Yeah, I've played some. I got the Ace Attorney Chronicles on the recent sale, and that's been pretty good. It's, you know, I've played a few of those Ace Attorney games, and they tend to be a lot of fun, and tend to do what they do very well. I'm gonna switch the music up. Yeah, so it's interesting. It feels like, you know, classic Ace Attorney, which is, I mean, you know, at its peak, Ace Attorney did what it did very well, like the whole courtroom investigation, all that stuff. So yeah, great Ace Attorney. I've never played through before now, and I'm like on the beginning of the second case, and it's so far like, yeah, that's Ace Attorney. That's classic. All right, so what we want to do here, I mean, I don't really want to, I mean, we could just do like, I don't care anymore. We could just do inverted dot mult back, and just be done with it. Oh, wait. But see, this is such a like ugly way to do this. I feel like we should just make it so that this returns. Wait, let's move this. Here. There we go. Now we can just do this. UV vector. This is for this. Merging. Okay, so yeah, it's just. Well, I guess it's a kind of a lot of. Do we have to do this way? Vertex info is making. Oh, I see. Because we have to multiply. I see. That's why we're doing it this way. Because then we feed the vertex info into add vertices. This is where we get in here. Well, we have to make a vector out of it anyway. But it's copy anyway. It's being copied anyway. So if it's being copied anyway, I guess we want to minimize the number of copies. So this is fine. We can do this. This isn't public facing. I mean, it is, but no one's going to use it. So it's fine. We can leave it the way it is. That's fine. All right. We don't need this anymore. Don't need that anymore. Don't need this anymore. Skin matrix 0. Turn vert out. Normal. Oh, I see. Bird out is well, we don't really need to do it this way. So let's do it this. Bird out once. Normal is up here. Y. Is this multivec or multivec double? Matrix mult, okay. Do this anymore. Wait, what? Oh, it's multiplying. Yeah, there we go. Bam, bam. This W. So that anymore. We don't need that anymore. Yo. Let's go. I almost missed that right there. Lucretia says, "What distro do you use again?" And Maxter the Turtle says, "I might be wrong, but I think he said Fedora a few streams ago." That is correct. I am using Fedora currently. I feel like it's a great Linux distribution for people who want like up-to-date software while also maintaining some stability. If you want just like pure up-to-date software, Arch or Manjaro is up there too. Probably Arch or like Garuda, something like that. Endeavor OS. If you want stability, Ubuntu, Pop OS. Solus is also really up there in terms of like on the cusp technology, but the thing about Solus is that it doesn't have a large selection of options of programs, so that's something you'll want to be aware of. But Solus is similar to Arch in terms of like, the process of if you don't like it, or if you're missing something and it's not available, you'll end up building it. So I like how like there's different distributions that allow you to kind of go at your own pace. So you can be like, oh, I want to choose this distribution for this reason, or I like this option more. I like that. I like that it's not just like, if you don't like Ubuntu, it's too bad. No, there's a lot of other options if you don't like Ubuntu. And Ubuntu is not a bad option. It's just multivec W. And that's V0. Yeah. Yeah, Ubuntu is not even a bad option. Lucretia says, I feel like I do like options a lot. The only reason I ask is because I'm going to partition my laptop for a Linux distro. Issue is that sometimes graphics card drivers don't work out of the box so easily, especially for AMD. Actually, for AMD, if you have a like AMD graphics card, you know, like a recent one, should be fine. AMD's been doing a lot of work with open source. Like they've been doing a lot of work to open source their graphics drivers, right? So it should be where it's like it's basically plug and play. You shouldn't have to do really anything. As opposed to Windows where you have to install your graphics drivers, or NVIDIA. On Windows you have to always basically install your graphics drivers. For NVIDIA you have to install your graphics drivers basically on Linux as well, if you want performance when playing games and stuff. But like for AMD, the open source driver that's packaged into the Linux kernel, as far as I recall, should be like top tier. So that's the upside of Linux, is like, you know, there might be more situations where maybe it doesn't work. Oh, this is supposed to be straight up like this. You know, there might be situations where you have to do some, you know, digging and stuff like that. But in situations where things should just work, it does just work. Like, it, you know, like if it works, it works. It works very well. Like package managers, like that's something that Linux has had for, you know, decades, and it's like that's such a no-brainer thing that, you know, would be fantastic to implement for Windows. Right there into the, is this distance? Yeah. Right there into the operating system. Okay. How did I miss this? Okay. Wild, I know, but we're done on that one. That's rotate back there. Scale. Okay. Ah, okay. Yeah, we're closing in on the end. I'm getting nervous. It'll have to be something like this, I guess. Oh, well, I guess we can just make it so that if the path has, yeah, we're just gonna just empty vector, that's fine. That, wait. This is actually, yeah, I could just say, there we go. This would be, Oh, whoops. Wait, what? Okay, return vector. I guess we could just say. There we go. Yo, we're done with this one. We're closing in. I'm scared. We're closing in. CVs. We don't clone this anymore. Don't need that anymore. Yo, no errors in the code base. Snowminx, sorry for ignoring chat, but yeah, Snowminx said if you do check out Hotel Dust Room 215, you'll see that it could have been it looks like it could have been made in Tetra3D. Yeah, I played it before I beat it. It was a fantastic game. I loved it. This song is so sick. Thank you, Lucretius. I appreciate it. Yeah, Hotel Dusk was just like Kyle Hyde, dude. Kyle Hyde was fantastic. A fantastic protagonist. Or you're like, did he actually shoot his partner? You know, what happened? You know, will you ever find out? It's such a good game. Just a really good adventure game. Very unique. There was a few like unique games like that, like right when the DS kind of started. I feel like that was one of the like launch year titles. Let's look it up. I'm interested. It launched in 2007. Okay. Oops. Yes. 2006 in the US. 2004. So 2004 to 2007. Okay, so it wasn't like launch year, but it was kind of early in the DS's lifespan, right? Because the DS kind of lasted a while. All right, so we will. It's time to fight this dragon. All right, Tetra3D vector. We don't use vector.vector anymore. New. Was 5? Okay, 0, 0, 5. I'm gonna make it so that this doesn't take a W. We don't usually need the W. Okay, so 0, 0, 5. Diff Y S MV. We're good. Regress. We're tight. Regress. Let's go. All right. So at the very least, I don't even want to see if it runs after all this. I feel like I'm nervous. I'm like, I know it's gonna crash, dude. Yeah, okay. But not even... Oh, that was my bad. Wow, it runs? It runs? No way, dude. It's not perfect. There's definitely some artifact here, I think. At least I thought. But hey, at least it runs. I think it's running slower. I feel like this was like a 0.35 millisecond scene before. Now it's like higher, but I'm not sure. We'll see. That's amazing. Yeah, it's amazing that it still works, but it's unfortunate that I don't think it's working. It might just be a matter of this actually should just be an edge. Yeah. It might just be a matter of it being like we're copying too much data, but maybe there's something else. Maybe there's a reason why it's not running well, unless I'm just not paying attention, like I'm misremembering. 22, 21, 21. No, that's faster. I think that's faster. 22. I don't know. Was it faster? I don't remember the previous like number. Let's compare. Okay, so firstly, we have, where is, okay, so I have Tetra3D from 0.10. I will also check out Tetra3D in its last state. Can we kick it over to index rendering, please? Okay, so we'll see. I think it might be faster, but I'm not sure, to be honest. I do not know. It could be, but I'm not sure. Actually, let me also close this before I forget. Now that I've been streaming for like 3 hours straight. Let's see. So we have, wait, where's the other one? Okay, I think this should work. So we have this is index rendering. This is the one that we were working on previously. This is 0.10 main, so we'll try this first. Go run dot. Okay, so 13, 12, 12, 13, 12, 12, 12. Okay. All right, this is shaping, this is good so far. 13, you know, okay, so we're looking at 12 to 13 FPS, all right, in the old one. All right. Cool. All right. We'll keep this on the side. You know what? Let's copy it out of here before I forget. Let me just copy this. Okay, so this is 0.10 main. All right, now let's go back to the new index, or the index rendering, which was the one, basically the build we had. Oh, why does it crash? There's no actual reason, right? Did I do something? Oh, did I do something? I don't think I did. Let me see. Releases. Index rendering. It might have been that last commit. This is unfortunate. I don't really want to. Okay. I don't quite know, but let's go back. In this example, what we'll do, let's go back. Let's go here. Do we have Git here? Do we have a Git repository? We do not. Is there any way we can download the code from a specific thing? All right, I don't know how to do this. So what we're gonna do, we're just gonna commit all this, making our own vector. Right. There we go. Push this. Okay, so now let's go back. We can roll back using this. I think this was yesterday. What did I do yesterday? Did I just commit it yesterday? 11 a.m. I guess I just committed it yesterday. All right, let's go back to this point. Fixing dots. Reset to commit. Hard reset. We can still pull it back. Okay, so now CD examples, CD stress. So this is the new version. Oh, this is not the stress test we want. Okay. So this used to be 15, 16, 15, 16 FPS. That is a massive improvement. That's twice. That's twice as fast. That's basically twice as fast. Going from 15, 16 to 22. Well, not twice as fast, but it's like 50% faster. That's massive. That's worth it. That's big worth it. Let me see. This goes here. Okay. Let's undo this. Let's pull what we have. Yeah, it does look like dramatically better. 21, 22. 15 to 22, that's like 25%. 15, 14 to 21, 22. Yeah, that's pretty good. That's pretty good, I think. There might be more ways I can make it even faster. Maybe if I made it flow 32s, that's possible. Maybe. But I think this is fine for now. This is already a pretty massive API change just to get to this point. That's pretty good, I think. That's pretty dope. Okay, so okay. Oh, this is main. This was 0.10 main. Okay. This is head custom vector. This is head indexed. We'll get rid of this out there. So it used to average 15.14 frames per second. Well, no, it used to average, once we were looking dead at this thing, it used to average 12.92 frames per second. Then with the index changes, it averaged 15 frames per second, and now it averages 21.6. 15.5 to 15.0 to 21.6. That's almost well, let's do the math. From 15.0 divided by 15.0 divided by 21.71. 69%? No. 21.71 divided by 15.0. My mind is not. Is it 40% faster? because 15.0 divided by 21.71, so 69%. So I guess 1 minus 0.690, that's 31% faster. Okay. No. It's 1.31 times? I don't know. It's, we gained, I guess it's 21.71 minus 15.0. That's 6.71 frames faster per second. Divide that by 21.71 and we get 30. Yeah, it's 30% faster. That's not right. No, that's right. Yeah, 30% times 15.0 gives you, or 1.30907 times 1.0. I don't know. I'm not sure how exactly I do the math. My brain is kind of thrashed. From 15% to 21% is greater than 25%. From 15 frames to 21 frames is greater than 25%. If it was 30%, that would be 5 frames. What am I thinking? Going from 15 frames to 20 frames would be an increase of 33% because you're gaining 5 frames, right? 15 divided by 3 is 5. If you add 5 on top of 15, you get 20. So going from 15 frames per second to 20 frames per second is a 33% increase. But we got more than that. So we got, I guess, 44, almost 45%. Okay. 45% FPS improvement. That's good. That's dang good. That's darn good. I'm happy with that. That's solid. That's solid. All right. I wish it was more. I wish it was more, but that's fine. That's fine. I'm probably going to also refactor all of these because I have to fix these anyway. I'm probably going to refactor all of these examples to use a common like example code because I do like that each example is standalone currently, but I would like it so that you could, for example, like press a button or something to like release the mouse, and you can't do that currently, which makes like getting screenshots and stuff tough. So it would be better if we could do that. I already know baking's not gonna work. Where baking at? I'm not used to also like doing this where it's like you specify a variable in a struct and then you don't have to specify it here if it's left at its 0 value. That's kind of nice. Something I'm just not used to. Vector. All right, anyway, I'm being stupid. This might not work though. I'm not sure. Yo, it works. Okay. Yeah, it's kind of crazy that this all is working. This is pretty good. I feel like it's not faster, but I guess I'm just misremembering. Is it not? Well, let's see. Let's see before we even. Let's see how it used to be in the old version of baking. Was it like 3%? 3 milliseconds? I guess, yeah, it was. I guess I was just misremembering. So this is almost upwards of like 2.8 milliseconds, 2.9. Sometimes it crosses over into 3. In comparison, this never crosses up to 3. Okay, it is better. It is just drastically better. Okay. That makes me feel a little better. Yeah, 44% is fantastic. I would say 44% is fantastic, considering how much time I put into this. Like, you know, this could be like a, you know, a week long kind of thing. It didn't take that long to actually do it. A lot of it, I mean, you know, that's kind of a testament, not a testament. That's kind of an overblown statement, but overblown vocabulary choice. But it's kind of like, I like how small Tetra3D's code base is, where I can like rip out a vector struct, make my own, and plug it in, and it's not like, you know, 1,800 files I need to change. All right, well that works. That works really well. It might be matrix. It might be that the matrix needs to be like replaced or changed. Like matrices need to be altered. Something I could also do that would be cool is I can now like change. I could change the vector. Oh, this was what I was gonna do. This can be right now. This can be up. This can be back. And then we could say left is right dot invert. Forward is back dot invert. Down is up dot invert. There we go. But yeah, something we could do is now we could make it so that the X, Y, Z, and W variables, instead of being float 64s, are a custom type, and then we could do something special with them, like add variables, add functions on top of them to do things like give me a random X or something. I don't know. It's just like you could do stuff with that. Like you can, you know, do something with this and be like, I want to do something special with it. I don't know. That's just an idea where you can make it like a channel, a vector channel can do something special in addition to storing and setting like normal. Like you can say like vec.y. I don't know, but I have plans. I have ideas. So there might be more places I can optimize as well, but this so far I think is pretty good. Stomach says, that's so good, more frame time for other things. I wonder how much speed gain there would be from not returning a vector in cross and add and multiply with reference and pointer stuff. I mean, like, I don't think so. I think as soon as you use a reference or pointer, it allocates the vector to the heap, and that's going to be slow. Like that's how it worked previously. We were using pointers to all of our vectors, and that was just slow. So I mean, there are times I'm sure where you would do better with a pointer. I think you could get some improvements by taking vectors and matrices in those methods by reference at the cost of API friendliness. Maybe I could use pointers in specific, like thrash heavy situations. Like matrices are already pointers essentially because they're an array of an array. So arrays of arrays. So it's already a pointer essentially. And functions that modify the matrix uses a why don't I, this could be that, but yeah, there's definitely ways that I can, well, that's fine. Yeah, there's definitely ways that this can improve But this is pretty good. This is actually really good so far, I think. I'm pretty happy with it. Matrix, maybe I need to make a matrix, matrix a struct too. I have to do some benchmarking on that one. I'm not sure. That seems like a lot of work to do, unless it's like, I want to make sure this mess would be worth it before I invest like 3 hours into just pure refactoring. Okay. I think we're good to clone that to make that a star. Let's not mess with it. No, I should be able to mess with it. I'm the developer. I can mess with it. I'm kind of surprised that this worked. I thought for sure there would be situations where I'm like modifying vectors directly and I need to not do that. I need to reassign to the original, but apparently I fixed all of the places where that needs to be a thing. Let me check animations actually. I know this won't work. Yeah. I'm kind of shocked that this is just working. Okay, yeah, that does not just work. 1, 2. Okay, so it looks like it just like I don't know. I don't even know where it went, dude. I don't even know where it went. You press the button, it just disappears. All right, well, I'll have to figure out what's up with that. It must be in my animation code. I'm pretty positive. Oops. That it's probably something like in here. Let's see. What feels sus? You know what? Are we getting here? I'm gonna see if I can just kind of like bumble my way through this because I kind of have a general feel. It's never getting here. Value as vector. It should definitely do that, shouldn't it? Like at some point it should. Rotation. Okay. Yeah, something out of the ordinary is happening. All right, well, the rotation is happening. AP animated properties, no.rotation. Okay, so that's happening. Okay, I think I know what's going on. I think I know what's going on here. I think the scale and position aren't being set, so when we do this, no. Oh, okay. Well, that's part of it. You can see that this is bad. Let me see. Let's just what do we got for props? Yeah, that's no good. So if props, animated properties. I guess if the property isn't animated, then we need to say it doesn't exist, essentially. So I guess the easiest way to solve this would be something like exists, scale exists, rotation exists, position equals position. Exists. Oops. Scale exists. Rotation exists. True. Okay, now prev animation. Oops. Prev animated properties equals map. Oh, so it just, I see, so it just copies it. Understood. Okay, so animated properties scale. Okay, right. Okay, the node, animated properties. Wait, animated properties. Oh, wait, I guess, hold on. Because we really only need this to be set. Like, in... Oh, no, that's right. I guess this works. Yeah, I guess this is fine. Position, yeah, so position exists. Okay, cool. So I think this is fine. We'll just go over here and undo this, redo this, and just say if start.position exists. Whoops. I guess I could just do it like this. There we go. I think that should probably fix it. It did not. Oh, if props.position exists. If props.scale exists. If props.rotation exists. There we go. There we go. I just feel like a general like I'm overcoming horrible not odds, but like I'm overcoming things that I shouldn't overcome. Like I was never supposed to make a 3D renderer, and yet here we are. All right. Very cool. All right. I wish I could get this to be sub 1 millisecond. That'd be good. Or even half. How would I do that? Let's try profiling this. Because like this isn't a complex scene. I mean, it's 2,000 triangles, so I guess it's relatively complex for a PlayStation style game, but still. What's Mr. Profiler got to say? Magnus says, amazing work. Thank you. Thank you very much. Snowmink says, it's too fast now. The table couldn't handle the speed of Tetra3D. That's exactly, that was the issue. It was just like, you're dead. It was just like, this is pretty good. This is a good sign if we have Seagull Call as like taking up time, because that means that it's like as fast as it could possibly be. Let's see. Let's not do this here. Okay. I mean, like, this can't really, I mean, like, not it couldn't get faster, but it is like we're kind of buttoned up against the barrier of human capability. Human capability, I think. Let's see what this thing says. All right, so we're still spending time on processing vertices. We could be faster on that. Slice is taking up 0.12 seconds. So 1.85 out of 2.73 seconds out of So out of 5 seconds, out of almost 5 seconds. Oh no. Okay, so out of 8 seconds in game, about half of it is spent rendering, performing calculations and stuff. Let's see. For each vertex index. I think it's probably this one, because it's clipping it, right? Yeah, so this is, I think, here. But it's not, it's in this function that we're spending 1.3 out of 1.7 seconds. So there is time to be gained in this function. I wonder if there's a faster way to perform these calculations. I imagine depth is part of it, because we have to calculate this for each vertex. But they should be in cache, right? So that shouldn't be an issue. Oh. Yeah, there might be a way around this. Might be good to break that giant function up into smaller ones, and you can see exactly where it's slow. That's true. But I think in addition, we're accessing different parts, and that's probably pushing things in and out of the cache. So it might be faster if we did this in, like you said, in multiple sections. Like the colors and vertex lights are always together. Let me see something real quick. All right, so it's like 21, 22, right? Yeah, like 20, 21. Okay. So what I'm gonna do, I'm just gonna take this out real quick. I want to see if we get a drastic increase from just not accessing the vertex colors. Oh, it needs to be do like that. So I'm thinking that we might be spending time no, it's not drastically faster. It is a little faster. So I'm thinking that basically we might need to do things kind of in pieces. Like, because processing the vertices happens all at once, right? Yeah. So I'm thinking that we might be able to do this like do all of the vertex or index. Do all of the vertex lighting at once, all the vertex colors rather at once, and the vertex lighting. Like all of that could be done. Well, maybe we probably just want the vertex colors. Like we do all of the vertex colors, then we do all the lighting, then we do. Because lighting's earlier, right? Yeah. Because that way we could get through. We could push more, I think, data to cache. Let's try it out and see if it makes a difference. It's only set to 0 there in the bottom of flush, yeah. But it's only plus here. Davi Lima says, how do you compile the raylib plus go to an executable? It should be mentioned on raylib go's GitHub repository. Yo, is it? It's almost 8? Dude, I started at 5, dude. I've been on this for 3 hours. It's crazy. Yeah, it should be as simple as just like go build, I think. I think you just go build dot if you have your go mod set up correctly. Okay, so what I'm gonna do, let's try this. This will be the last thing we do. Because we need to increment vertex list index here. Okay, so we'll say OGB. We can do this here. Oh no, that's right. Okay. OG vertex list index. Okay, so here's what we're gonna do. We'll see if this actually makes a difference, because I'm thinking this has to do with like the cache and stuff. We will say that the only thing we want to do in here is clip, set the color and depth. We will do only this stuff here. Then we set vertex list index to be OG vertex list index. Okay. Then we do this again. And this time we just do vertex colors and lighting. You know what? Just vertex colors. Let's see. We'll try it like this. We'll just do the vertex colors. We'll just do the lighting. So I want to see if basically yeah. And just lighting. Gonna move this out here as well. No, we don't need this. I can just kick this out. Move this. And then here, we pick this up after this. Where if we're rendering depth, then we do this. Oh, we need U and V. All right, we'll do this up here. All right, so this is an idea. Let's see if it makes a difference. Seems about the same. Most Linux distributions install G8CC by default, so if RayLib uses CGO, it probably just works on Linux without much hassle. The story is probably different on Windows. Yeah, if you're, yeah, I'm not using RayLib here. Firstly, but secondly, if you're on Windows, then yeah, you have to probably install a compiler. Yeah, it might be easier if you're on Linux. Building for Windows would involve a cross compiler. So you would need to install a Windows compiler essentially on your Linux machine, which is not even that difficult if you have something like Fedora, or I think Fedora might have one, but Arch or Manjaro, something like that, where you have the Arch Linux repository. Otherwise, if it's not in your repository, it's going to be a little difficult. But I think if you're just trying to build a Windows executable and you're on Windows, it's probably going to involve a CGO compiler, a C compiler that you'll have to install. It feels like this should be like something to increase the speed, but apparently not. But it definitely feels like this. I'm like, this is something that's important. Because here we can loop through all of the vertex lights at the same time. I'll have to look it up. I wonder if there's a way to see when we have cache misses, because that might be part of it. Anyway, I'm done. I'm so done. Thank you very much for watching. We managed to get a pretty good amount of work done. We managed to speed up Tetra3D by like 40%, which is massive. Yeah, like that's not a small thing. A lot of refactoring, but it came out good. Came out, you know, with some improvements. Yeah, so thank you very much for watching. I've been SolarLune. It's been fun. I'll catch you guys on the flip side next time. And if you want to support development, please check out the links in my description for master plan, for my Patreon, and I think I'll be adding some tiers to the Patreon supporters, to the, you know, what you'll get if you support through Patreon. I've been making some bootleg like beats and stuff using samples that would be fun to put on the YouTube channel. So you'll be seeing some stuff from me, hopefully coming soon. But anyway, thanks for watching. It's been real. I'll catch you guys on the flip side, and thanks for watching. Yeah, see ya.